From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
I just gave a guest lecture this semester in our manufacturing processes class here at Mines. And so they gave me one lecture to do additive manufacturing. And so I was like, okay, what can I get across in 1 hour and 20 minutes where this might be the only thing they'll ever see of additive manufacturing? And so the way I approached that lecture was going through the 7 different classifications and describing how the processes worked and some of the applications that are already out there.
That was Joy Gockel. Joy is an associate professor in mechanical engineering at the Colorado School of Mines, and her research spans several aspects of additive manufacturing. She joined Mines from Wright State University, where she was an assistant professor in mechanical and materials engineering. Prior to her faculty position, she was a lead engineer at GE Aviation's Additive Technology Center. She earned her PhD in mechanical engineering from Carnegie Mellon University and received her BS and MS degrees from Wright State University. She has been awarded the 2020 ASTM International Additive Manufacturing Young Professional Award and the 2021 TMS Young Leader Professional Development Award as well. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Joy, thank you so much for joining the episode today. I know it's a busy week for you with DMC kind of in your backyard, so appreciate the time, kind of pre-kickoff to that. But I'm excited for the conversation today. We like to kind of get into people's career paths on the podcast. And like we start with everyone here, I like to kind of get context for where you came from. How do you kind of get to this path? So let's start at the very beginning. So where'd you grow up? Where you're from? Kind of what kind of put you on the path towards manufacturing, engineering, materials?
Yeah, sounds good. So I'm originally from Ohio, Springfield, Ohio. And I decided to go into engineering for my undergraduate, basically right before I started my undergraduate. Actually applied to the university that I went to, Wright State University, undecided between engineering and music education. So I had a little bit of an uncertain career path in the beginning. I think I ended up bringing some of that education side in with becoming a professor eventually, but I chose mechanical engineering because it was a very broad engineering discipline. There were lots of different opportunities that I could potentially go into. And then I ended up getting my start in additive manufacturing during that undergraduate time. So I was part of the university honors program, and one of the requirements was to do a research project with a faculty member. So in talking with different faculty members, there was one that I had enjoyed his classes, and he had this opportunity where he told me about this manufacturing process where you used a laser to melt the material and build it up instead of machining away the material. And so it was really interesting because I had never heard of additive manufacturing at that point. We did not have printers in my high school like there are a lot of now. So it was the first time I had heard of it, and it sounded like an interesting technology. So I started doing undergraduate research and then continued on to a 1-year master's program to kind of finish out that undergrad research. And through that opportunity, got connected to the PhD program at Carnegie Mellon, also staying in additive manufacturing. So it's been a research area of mine for quite some time. About halfway through my PhD is when I would say additive really started taking off, and there were a ton of applications and it's starting to be applied in industry. So I gained a lot of those fundamental additive skills and knowledge during my PhD. I had gone for my PhD saying I wanted to be a professor. And then I got to the end of my PhD and I said, that was a long time of school. Maybe I should try something else first before I stick in academia forever. So I took a job at GE Aviation in their Additive Development Center in Cincinnati, Ohio. And that was really a great experience to give me a lot of perspective. So I had done modeling during my PhD and a couple different types of processes and really digging into the fundamentals. And then I got to apply that in industry, doing process development to say, okay, we want to build this part. We need to develop the manufacturing process for it. And I really saw that there were a lot of fundamental issues that were still there. So that kind of led me back to academia. I really like to know why behind everything. So I like digging deep into problems, and academia is really the place to be for that. So that was my next career move, is I moved to a faculty position back at Wright State University, where I had done my undergraduate. And I spent 6 years there doing additive manufacturing research. We looked at a lot of different aspects of the processing structure properties relationship, doing modeling, experiments, mechanical testing, really trying to close some of the gaps of, if we're trying to optimize the process, what are we trying to optimize towards, and understand some of that fundamental materials behavior. And then this fall, I just moved to Colorado School of Mines, to a position here where we're continuing to really push in the additive manufacturing space with a lot of new equipment and a lot of new capabilities, and building on further understanding, bringing together a lot of different areas of expertise, because additive is so interdisciplinary, lots of complementary skill sets, and pulling together some of the larger understanding that we need.
Awesome. No shortage of topics for me to dig into today on that one. So I'm really curious. I mean, you started with kind of, you're looking into music education and then engineering. So tell me more about that story. Like, did you have people in your, like, did you play music growing up, like in your family? Like, was it an engineering family, or like, what was the dynamic there?
Yeah, so it was both. And I think that's kind of what influenced the decision. My mom was a music teacher for elementary and middle school. And then my dad was an engineer, a mechanical engineer, but more on the thermal fluid side. I'm more on the solid mechanics side. We do still talk to each other though. And so I think that's what I saw a lot of that influence. And I knew what engineering was, because that's another thing that's kind of changed in education since I went through high school. There's a lot of high schools with engineering programs now, and really exposing more of that technology earlier. And I've always done music. I still sing. That's really the one thing that it has continued through. But I played 3 different instruments through high school, and really enjoyed that creative outlet. But I decided it could always be a hobby. So I continued with music as a hobby, singing in a couple of different choirs, even up until last year. Still looking for a choir here in Golden to join. But I think there's been a lot of studies really connecting music and technology in how people think, and looking at patterns in music. So I think they are well tied together. But I'm glad I've been able to keep both as part of my life.
Yeah, one of the questions I constantly get, especially from kind of young engineers who are coming up the ranks, is like, kind of, how do you build that skill set that's relevant for additive manufacturing, given it's so broad, right? And so as you were kind of, I mean, as you were building kind of your career, like it was still an emerging, there's a lot of changes going on in the industry, which they're still now, but kind of from everything that you've seen in the academia sense and the GE Aviation sense, like, what have you seen as like, hey, like, push everything aside, if I had kind of these top skill sets, I'm going to be fine?
Yeah, I think that's a great question, because I would start with just saying I'm still building. I'm still building the skill set that's really needed to understand all of additive manufacturing. I started with a lot of the fundamental kind of heat transfer side of things, looking at melt pools. I always say that the melt pool is the most fundamental aspect of at least metals additive manufacturing. So understanding how that melt pool changes with the manufacturing process was really a key fundamental building block. But then as I've continued my career, there's really interfacing a lot with materials. All of my degrees were in mechanical engineering, but all of my thesis titles had the word microstructure in them. So I've always kind of towed the line a little bit between materials and mechanical engineering. So that is where I think the really critical materials, manufacturing, design aspects tie together. Actually, during my time at GE, one of the things that stuck with me was a conversation with one of the executives, where he was talking about the fuel nozzle development, which, that's one of the classic examples that we give of a successful first application of additive. And from the team perspective, he said when he would talk to the team that was working on this project, he couldn't necessarily tell who the materials person was, who the manufacturing person was, who the design person was, because they communicated so well and understood what everyone else was contributing to the project that they were able to talk all of the different languages. So really crossing over the design, materials, and manufacturing process is critical. But then I've continued to build skills in, understanding laser optics for the lasers type processes. What is the laser material interaction? What are the potential sources of variation in that process? And I think that's where the collaborative nature and interdisciplinary nature really helps in additive. A lot of the directions that I've gone are because I've had collaborators that have been willing to teach me and work with me. And we've, kind of teach each other to be able to work in these different areas and bring all of it together. So first bringing together kind of the first fundamental pieces, but then being willing to learn for the rest of your life, and talk to people in the different areas, and start building those additional skill sets.
Yeah, I think that's so important, that humility to kind of realize that there's a whole host of things out there, and especially in a team, right? I mean, companies that I've worked with and seen, just like you're saying, is the ones that are successful kind of have that kind of good balance of hey, we know what's going on, but I don't know everything. I need to be able to communicate kind of this part of the process to the materials person or the design person, have that kind of constant flow of communication.
Absolutely.
And so we were talking a little bit before we press record about kind of this idea of process and process selection. And so let's talk more about that in terms of, as we've seen today. I mean, there are certainly big categories of additive that have a lot of focus. Metal powder bed, right? That's kind of the hot item for the last few years, but that's only one of several processes. So as you kind of have seen over your career and a variety of different processes and different materials, what are some observations that you've had with companies you've worked with or people you've worked with as just industry general of kind of that process selection piece?
Yeah, so we say additive manufacturing, and then that means something very different to lots of different people. So the processes in themselves are all fundamentally the same, where you're starting with a computer model and you're ending up with your part in a layer by layer process. But the material properties are very different. The design rules are different between different processes. So there's a lot that has to be considered in the overall, this is my application, this is the best additive process for that application. And so that's how I try to approach education. Also, I just gave a guest lecture this semester in our manufacturing processes class here at Mines. And so they gave me one lecture to do additive manufacturing. And so I was like, okay, what can I get across in 1 hour and 20 minutes where this might be the only thing they'll ever see of additive manufacturing. And so the way I approached that lecture was going through the 7 different classifications and describing how the processes worked and some of the applications that are already out there, strengths, weaknesses of the process, so that when these students, who are all mechanical engineers, they likely won't work in additive manufacturing unless they go on for additional courses in additive, but they'll be in a design role and have to be able to say, this is the best process for additive. So being exposed to those different processes, I think, is really critical. And usually at that stage, everybody's only heard of material extrusion, desktop type printers. They don't even know you can print out of metal. So passing around parts and showing the different capabilities, I think is really eye-opening and gets people thinking about how do we take this paradigm of additive manufacturing and really implement it in the best way possible for future positions. So there is a little bit, I think, in the industry right now of adopting a single process and then using it for all of the applications that could benefit from the additive benefits, like complexity, combining multiple parts into one, if there's a part where that's applicable, then let's just build it with laser powder bed fusion, without really thinking about, do we need the complex internal channels? Do we need the characteristics of laser powder bed fusion? Or is there a process that might be faster and cheaper that you could select for that particular application? So I think thinking about additive as a broader construct, and thinking about the different strengths and weaknesses of the different technologies that are out there. And I'm sure there will be more that will be developed. So in order to really adopt additive and take advantage of everything that is still to come in the process development side, we need to be agile towards different processes in our implementation.
Yeah, and it's that dichotomy, right, where there's like, you show people these technologies, students, it could be people at a company, and they get excited, right? See what you can do in these designs. And then in some cases, I've seen an over-reliance on, hey, like, can you print me this cube? We know you can print it, but is that always the best usage of time and resources to do it? Certainly at the prototyping level, I see that all the time. We're like, okay, we can print it just because we can print it. Like there's, and so there's a level of overuse sometimes, or over-reliance on the technology, where like you might have better options to do it. But
yes. And not even just within additive too. Mm-hmm. So also considering just traditional machining. I've worked with a lot of senior design teams where they'll bring a part to me and say, can you print this sheet with 2 holes in it? And I say, have you talked to the machine shop yet? You can get a piece of aluminum and then drill 2 holes in it. And I think that is a critical piece. So not just thinking about additive process selection, but traditional manufacturing, traditional machining. Is there an easier way that may still be faster than printing a part, just because that's the tool that you have sitting in front of you? It's not necessarily the best one.
So now that you're at Mines, kind of what is, can you dive a little bit deeper into kind of what a day in the life of a professor, like what does that mean? Like what sorts of things do you do, and what's kind of your job role?
Yeah. So I've only been here a couple months, so I'm still kind of figuring that out. And the nice thing about a faculty job, at least what I enjoy about it, is it does change very frequently, especially just every semester, because of whatever you're teaching and what that schedule looks like. So a lot of what I've been doing so far is really just starting to engage with the additive community here, is what I'll call it. That's one of the reasons that brought me to Mines, was the collaborative environment and the complementary skill sets that really lead towards those collaborative interdisciplinary type projects like what we talked about earlier. So working with the other faculty members, we have some larger projects where we are working together on these larger projects, which gives us the construct to do that. But then just talking with each other and inspiring future ideas, working with students, lots of cool lab toys, which is another reason that brought me here to Mines. So working with the additive equipment that we have here and getting some additional equipment set up to be able to have that capability. Right now, I'm also on a big student recruiting push. So trying to get some new students started here at Mines, thinking about building the program throughout the next couple of years. I like to have a good mix of students from undergraduate to PhD working on the different projects and different levels of experience and different types of things, different types of careers that they're building towards, whether we're training undergraduate students for industry careers or training them to become graduate students, really getting them hands-on in the lab and getting some of that additive experience is one of the things that I'm really trying to engage with.
And what's your philosophy on kind of recruiting students? What's the pitch?
Yeah, I feel like I'm really good at selling Mines right now because I just decided to come here. So I had all of the things fresh in my mind. But really recruiting students is, from my perspective, really trying to build the appropriate mentorship plan for their career goals. And a lot of students don't really know what they want to do. I mean, I came in saying I wanted to do one thing. I did end up being a professor eventually, but I took the little side industry path. So there's lots of growth from that area. But in getting students in, it's talking about the different experiences that they can expect through a graduate program. And that's both from the technical development side and the professional development side. We're really preparing them to be our peers. So building research skills, how do you form a hypothesis? How do you really dig into those fundamental type problems? And then how do you communicate your results? So going to professional conferences and gaining those networking skills and communication skills that I think are really critical in a professional environment. So we really try to build a lot of those skills into an overall graduate program. We think about classes, we think about research, but it's also the professional development side.
Yeah, and I imagine too, the area that you're in, kind of the Colorado area, the students are able to see people like them succeeding in the industry, whether it's at 3D Systems or Lockheed or Beehive or any number of the different kind of additive companies in the area that are around, right? Elementum and things, that you have people that have walked the path before, which I think is super helpful. Like people that you can build your network with.
Yes, and we have a lot of industry engagement here at Mines also, and kind of a push towards making sure that we are industry relevant and we're solving industry relevant type projects. We have an industry consortium called ADAPT, where we have quarterly meetings. We actually have one of them coming up this week, where the students are directly engaging with the industry members. So I think that's one of the reasons why the industry members want to be engaged with us also, is to recruit students. So they're all looking for future employees and looking for what types of skills that they need in their employees. So having that engagement throughout the graduate program, whether it's a PhD student or even our additive manufacturing master's program here, is also heavily engaged with industry. So keeping those connections and figuring out what the best skills are that students need.
And do you have to also kind of frame a research area / topic, or is additive manufacturing broad enough to account for that for your own work?
Yeah, it's a question that I've always been trying to answer of when people ask you what your area of expertise is, because I think 5 years ago, saying additive manufacturing wasn't really a recognized area of expertise. So, a lot of people would say, I'm an expert in solidification, or I'm expert in phase transformation, or these different pieces of additive. But I think that we're really seeing a shift of where additive manufacturing is an area of expertise. And so understanding how the processes work and how all of the different parameters, whether it's like a processing parameter like laser power or speed, influences the process, but then also understanding how the machines work. So from like a machine design perspective, how does the gas flow impact the process? So there's all of these different things that I think do lead up to an additive manufacturing area of expertise. I tend to phrase it that I just work in all aspects of the processing structure properties relationship, whether it's process monitoring from the processing side or fatigue testing from the properties side. Those are the areas that I've gained expertise in, kind of working within the additive construct.
I think the really neat thing about kind of what you have at Mines is, you mentioned it a couple of minutes ago, is that industry connection. And you've got some projects certainly with industry, but also with some of the big institutes like America Makes. So do you want to talk a little bit about kind of some of the work you're doing in that context?
Yeah, so America Makes is an organization that I've been involved with actually since their beginning. My graduate advisor invited me to come up to this meeting in Youngstown. I really had no idea what I was going to, but I was at the very first America Makes meeting, and I've in all of my roles since then, been engaged with America Makes. So through graduate school, through my GE position, through Wright State, and now through Mines. And I think that goes back to keeping a good perspective in the area of additive research, because it is such a fast moving field where you are seeing advancements that are happening in industry, but then finding the research gaps and those niches that industry can't take the time to solve because they have to develop products and advance in that way. I think organizations like America Makes really help keep the pulse on engaging industry and academia and government organizations together to see what are truly the gaps that are still existing. And also engaging from the technical side and the workforce development side, engaged in all of those types of activities, and then having the connection to industry needs.
For sure. Yeah. And it's one of those things too, where I get to see it because I work with a lot of different companies, but there's a lot of repeated efforts across the industry, yes. Whether it's qualifying an M290 for titanium or aluminum or stainless, right? Like it's been done a million times at this point, but everyone has to do it from scratch. And so the ability to have an overarching institute across the country to look at some of these broader problems and have specific working groups that kind of say, hey, like we're all kind of saying the same thing. We're all trying to work on these types of challenges. Why don't we put out a project that we can share broadly to the membership and maybe help accelerate that adoption a little bit quicker to help U.S. manufacturing? Absolutely.
I think the construct of America Makes is really one of the things that is pushing the industry forward for those very reasons that you mentioned. You're going to spend $1 million collecting data. You don't want to share it with someone else because that gives you your competitive edge in industry. So identifying the pre-competitive aspects of additive that will really help the small and medium-sized businesses advance as well, because a small business doesn't have the ability to spend $1 million developing some data to advance their technology. So finding and filling those gaps. One of the efforts currently is a refresh of the America Makes roadmap. So I'm have recently taken the role of the materials swim lane lead. So we're working on material specific aspects. We just had a road mapping activity at an event, America Makes event in August, trying to identify some of those new gaps. So it's a constant, fast-moving field. So remaining agile and finding those gaps and getting input from industry of what really needs to be solved that maybe they don't have time to work on also. What is useful community knowledge? Absolutely. And so could you explain a little bit about what you guys are on a project at Mines. Can you talk broadly about kind of an example of solving some of those problems? Sure. So the project that we're working currently through America Makes is in collaboration with Army ground vehicles. So we're looking at qualification of additive processes. Our focus right now is looking at a stainless steel 316L for some Army applications. But as you're building a component, your material is built at the same time as your component. So there's some variation depending on exactly what geometry you're building. And then that could influence your overall properties. And so that's one of the areas that we're trying to look at currently is as we're building material in a single process, a single machine, even right now, what is the variability? How does that impact an overall qualification construct? And digging into some of the interdisciplinary aspects, using advanced like machine learning to manage some of this large amount of data that you end up with in an additive process is another area of that focus. I always say I'm a data collector, and then I get into trouble because I want all of the data, and then being able to process it and really use it and find all of the correlations that exist is where we're bringing in the machine learning area and being able to process some of that, whether it's in situ sensor data or microstructure or properties information, to really draw some of those connections that'll help us be able to come up with how do we qualify a part in the future.
Yeah, and as I mean, I live that kind of world on a daily basis. I almost think it's like Hoarders, right? Like the TV show where you have so all these organizations that want to collect a lot of data, but the amount that's actually useful or that you could actually get like any semblance of patterns out is so small kind of with today's tools that it's overwhelming, and sometimes it's almost better not to collect the data. Just so I mean, people say like, hey, we want to save it for like 3 years from now when we can look at this, but I'm like, your processor going to be all changed. You're going to be at a new machine. Like don't worry about it.
Yes.
But it's
yeah, I think some of the fundamental problems that we're trying to answer is, when is it important? Mm-hmm. If we just talk about the process monitoring side, in some of the work that I've done in the past, you can see process signature changes before you actually see any significant change in the material structure. So defining some of those relationships, I think, are going to be really critical in deciding what data do you keep, what data do you not have to keep, to be able to actually find significant changes that are going to impact your properties. Some process fluctuations are probably okay, but we don't really know the answer to that yet.
Yeah, and it's such a tricky problem, and I'm glad there's super talented people like yourself working on getting to the bottom of all these. And so as you kind of continue to kind of grow out your career at Minds and with future students, I think one of the things that I'm always curious about from kind of trying to put myself into the shoes of a student going into kind of a new track, or understanding kind of what is it that I wanted to do with a degree that's specific to additive manufacturing. Like, what are kind of the job paths that you see being most popular from kind of graduates or even colleagues that you've worked with over the last few years? Are there kind of trending, any interesting trends or descriptions that people can take away?
Yeah, so I think the first interesting trend that I had was from early in my academic career. I had several master's students that graduated and got jobs in various places, not in additive manufacturing. And then I have since talked to them a few years later, and they are now in additive manufacturing because their organizations found out they had some background knowledge in that area. So it was more they were looking for specific locations for a job, geographic locations, and just kind of finding the opportunities that fit. And now, one of them has the job title lead additive manufacturing engineer, but started at the company in nothing related to additives. So I think there are a ton of opportunities, and really organizations are looking for some of that additive manufacturing expertise, whether it's going into industry, where you're developing products. There's research going on in industry as well. National labs have been hiring quite a few people, doing heavy research in additive manufacturing. You go to an academic conference, and half of the presentations are from different government or national labs across the country, really pushing in those areas as well. So I know right now, I don't know if there's trends in where people are going, but there's a ton of job opportunities. I'm contacted by people frequently looking for expertise in the additive area. So I think the opportunities are really ripe for whatever career path fits the employee the best, of what type of environment, what level of research versus product development. But I do think we're seeing more advanced degree in the professional world. A lot of people working in additive manufacturing do have some sort of advanced degree, even past a bachelor's. That is one thing that I've seen recently. I don't know if that necessarily has to be the case, but that is where a lot of the more additive specific education happens. You can get a technical elective and a bachelor's, but to really dig deep and get more of that knowledge, it's in the higher level programs currently.
Is that how it's structured at Mine? So if students are kind of looking at opportunities for increasing their additive education, is it a master's program, is it PhD research, but any undergrad stuff as well? How does it work specifically there?
Yeah, so we have several courses that are cross-listed, both undergraduate and graduate. So depending on how the students have structured their undergraduate program, like specifically in mechanical engineering, you could take our core additive manufacturing classes as an undergraduate student, but it would take up all of your technical electives. So you basically have to know that you want to do additive manufacturing and then go that path, which is definitely something that you can. And then that also allows you the potential to pick up a certificate in additive manufacturing if you take the courses that make up that. So you do get a credential that is focused in additive manufacturing that you can get as an undergraduate student. But then most of our additive specific education is at the master's level. We have a non-thesis master's degree. Right now it's called advanced manufacturing, but it's basically additive manufacturing with some breadth of manufacturing technologies built into that program as well. So we'll get a lot of students that'll come out of the undergraduate program, and then the master's program is designed in the non-thesis construct to be, a year to a year and a half, very industry focused for students that are interested in that path. And then the more research side is the PhD program and working with different faculty within different departments. So we're trying to push education at all different levels. A lot of students will take our first additive manufacturing class as an undergraduate to get that exposure and experience. That's why I'm also doing things like guest lectures in the manufacturing processes class, just so students are getting exposed to what additive manufacturing is and how they may be able to learn more about it if they have an application that fits. We're also working with high schools and career centers in the area that honestly, I'm jealous of some of their labs because they have awesome equipment and they're really doing a lot of great things, especially in the polymer space at that level of education. But it's an interesting time from a workforce development education perspective in additive, because you have high schools that are getting exposure to the technology so quickly. So now the students that are starting as freshmen in high school, we're going to have to construct our college curriculum a little different just because they already have those ideas coming through. And I'm also working a little bit in some professional development courses, teaching a class in metals, processing structure properties through TMS. And the curriculum overlap between what we want to teach high school students right now versus what we still have to teach professionals that had none of that exposure, there's a lot of overlap just because we're in that adopting phase of where people have seen what in additive. So I think it's another continuous improvement thing. So really keeping a pulse on what students need to see at the different levels of education and how additive manufacturing can be integrated lower and lower.
Interesting. So I guess one last question, then I'll let you get on with your DMC week. So what are you excited about for 2022? So we're kind of at the end of the year now. So what's on your radar, either kind of industry related, your career related? What are you excited about?
Yeah, so the thing I'm most excited about is some of the new capabilities we're getting in here at Mines. I mentioned lab toys earlier. So we have a laser powder bed fusion machine currently that was just installed this summer, shortly before I came here. In the next year, we'll be getting another laser powder bed fusion machine, some sort of blown powder DED machine. We're getting a robot arm for a wire arc system. So it goes back to the process selection and understanding the different types of additive manufacturing. We're going to be getting a lot of those types here in the lab and being able to work with the different types of technology. I fall in the classification of I've been mostly laser powder bed fusion metals for the past 6 years with a couple other projects sprinkled in there when I could find a collaborator with a different type of equipment. So I'm excited to have a lot of new lab capability and really be able to expand research and start pushing a lot of the different aspects of additive forward.
Awesome. Well, thank you so much for spending some time with us this morning, and look forward to seeing you in the new year.
Yeah, thanks for having me. It was a great conversation.